Okay, first let's consider the ln of x over x to the power of p. If we differentiate that, we get p ln of x, p minus 1 times by 1 over x times by x at the bottom minus ln of x to the power of p, differentiate the bottom, and the bottom squared. So that turns into 1. So we have, we can factor out ln of x to the power of p minus 1, and we get p times ln of x minus 1. So this is always positive, and this is also always positive, right? Provided that x is greater than or equal to 1. If it's actually equal to 1, it's 0. The whole thing will turn into 0. Okay, but provided it's greater than 1, this is always positive. So the whole thing will be negative if p ln of x minus 1 is negative, which means when ln of x is less than 1 over p, which means when x is less than e to the power 1 over p. Okay, which is not good. So, but note that when I divided both sides by p, I assumed that p was positive. If p was negative, this would have actually flipped. Okay, this would have flipped. So what we want here is that we want p to be negative. Okay, p is negative. When I divide both sides by p, we get a negative value. That means x, as long as x is greater than e to the power of 1 over p, so we get some negative value as an exponent, but this is still going to be a positive value. All positive values. This is good, right? So, for example, if p was negative 2, we would get, x is greater than 1 over e to the power of 1 over 2, right? 0.6, which is perfect, which is what we want. We want this to be decreasing when x is greater than or equal to 1. Okay, so far we have p needs to be negative. So let's check the second case. The limit of n approaches to infinity for ln of n to the power of p over n. We've got to use L'Hopital's rule. Differentiate the top and bottom separately. So we get p ln of n, p minus 1 times by 1 over n over 1. Okay? So, we can just write that this way, n at the bottom. So we kind of have something similar to what we had here. Time, we get p times p minus 1, right? And we get ln of n to the power of p minus 2. And then we get 1 over n again. I seem to be approaching a particular value here. But note that if p was negative, or actually negative or equal to 0, if negative, this whole thing goes to the bottom, so it's going to obviously approach 0. But if it was equal to 0, 1 over n will still approach 0. In fact, here, if p was 0 here, it'll equal to negative 1, which would make the whole thing always negative. So we should actually include equal to 0 here. And this also works for up here as well. And therefore, p should be less than or equal to 0 for it to be convergent, so that it satisfies both alternating series test